Hey guys, welcome to lesson 12. This is the beginning of another subunit, the last subunit we're going to do for unit 6. Lesson 12 is on the meaning of exponents. So let's look at our learning targets. I can evaluate expressions with exponents and write expressions with exponents that are equal to a given number. And I understand the meaning of an expression with an exponent like 3 to the 5th power. So just to kind of front load some information, 3 to the 5th power is an exponent. It's written like this. Notice the 5 is in the tiny little corner right there. That's 3 to the 5th power. And what that means is 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3. So for instance, if I had 2 to the 4th power, a 2 with a little 4 in the corner, that would be 2 times 2 times 2 times 2, 4 times. Anyway, I just wanted to front load some of that information. We're going to get into it more. Anyway, so for 12.1, it gives you this image. It's asking, what do you notice and what do you wonder? So take about a minute or two, pause the video, write down 2 things that you notice and 2 things that you wonder, and then unpause it when you're done. Okay, hopefully you paused the video and you did that. So some things that you could have noticed are that it looks like a hexagon. You could have noticed that there's different colored dots and that there's more and more each time. You could have noticed that each dot has 3 connecting to it. Okay, you could wonder how many would be in the next layer. You could have wondered, why is it doing this, or why this pattern? Okay, I just want to point out that the first black dot has 1 dot, and then the next has 3, and then the one after that has 1, 2, 3, 4, 5, 6, 7, 8, 9, and the next one has 27, and so on. So each row is actually going up by a multiple of 3. So 1 times 3 is 3. 3 times 3 is 9, and 9 times 3 is 27. So the blue row should be equal to 27 times 3, which is 27 times 3, 81. So if you really wanted to know what the next row would be, you could go ahead and follow that pattern and do 81 times 3. Let's go ahead and look at 12.2. Okay, this is a cool problem. It says you are walking along and you find a brass bottle that looks really, really old. There appears to be some writing on that bottle. You try to clean off some dirt to read it better, and a genie appears. He is so happy to be free, he wants to repay you. He offers 2 ways to repay you, and you must choose one. So either he will give you $50,000, or he will give you a magical $1 coin. That magic coin will turn into 2 coins on the first day. The 2 coins will turn into 4 coins on the second day. On the third, the 4 coins will turn into 8. And the genie explains that the magical coins will continue on that pattern for 28 days. So we have 1 coin day 1, we have 2 the next day, then 4, then 8, and it's going to keep going. So this is day, and this is coins. So we already know day 1 you have 1, day 2 you have 2, day 3 you have 4, day 4 you have 8. So you're trying to figure out if you will have, how many coins you will have. So it's going to keep going all the way down to 28. Now, number 1 says the number of coins on the third day will be 2 times 2 times 2, right? Oh, I'm sorry, I did this wrong. This is day, oops. On day 1, we're already at $2. Okay, sorry. It says the number of coins on the third day will be 2 times 2 times 2. Okay, can you write in another expression using exponents for what it will be on the third day? So an exponent, remember, is that little number in the top corner. So if we're taking 2 and we're multiplying it by itself 3 times, the exponent is going to be a 3, because that is the number of times we're repeating 2, the number of times that we're multiplying it by itself. Now, it's really important that you note that that does not mean 2 plus 2 plus 2 or 2 plus 3. 2 times 3. It does not equal that. It's equal to 2 times 2 times 2. Okay? All right. So that's an exponent for the third day. Now it says, what does 2 to the 5th and 2 to the 6th represent in this situation? Okay, so 2 to the 5th means 2 times itself 5 times. So 2 times 2 times 2 times 2 times 2. Go ahead and figure out what that would be. Now 2 to the 6th is equal to 2 times 2 times 2 times 2 times 2. Figure out what that would be. Go ahead and pause it, figure these out, and then unpause it when you're done. Okay, so for 2 to the 5th, we have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is, my gosh, I need to do that. Oops. Oops. 32. Okay. Now, 2 to the 6th is going to just take this a step further, and we're going to do 32 times 2. And so we're going to end up with 64. So in this scenario, 2 to the 5th is representing how much money we are going to have on the 5th day, and 2 to the 6th is representing how much money we're going to have on the 6th day. So on the 5th day, we have $32. On the 6th day, we have $64. Now it wants to know how many days would it take for the magic coin to exceed $50,000. Okay. So you're going to have to keep repeating that. So 64 times 2, that would be the 7th day. And then the answer to that times 2 would be the 8th day. And then times 2 would be the 9th day. So it wants you to repeat it until you get up to $50,000. And that may seem like a lot, but it's actually not as much as it seems. The question is, will the value of the magical coin exceed $1 million within 28 days? So try and figure out how many days it'll take the coin to get past $50,000. There's a little applet here that demonstrates kind of what that looks like. I'm going to go ahead and show you here. Okay, here's your applet. Day 1, day 2, day 3, day 4, day 4, day 5, day 6, day 7, day 8, day 9, day 10, day 11, day 12, day 13, day 14, day 15, and look, oh, day 16. So, going back to that, you can see that it keeps doubling and doubling and doubling, and it gets to be a huge amount. So your two things you're trying to figure out is how many days it takes to exceed $50,000, and is that going to be within 28 days. So once you figure those out, you can figure out which choice you would prefer, which deal you would make with the genie. I'm not going to give you guys the answers to this because I think it takes away some of the fun. So go ahead and work on that. Unpause the video when you're done. I'm going to go ahead and look at 12.3. So 12.3 is giving us some examples of expressions involving exponents. All except one of them equals 16. So we need to find which one is not equal to 16 and explain how we know. So let's go ahead and look at the first one. 2 to the third power times 2. So remember, this is not 2 times 3 times 2. It's 2 to the third power, which is equal to 2 times 2 times 2. Okay? 2 times 2 times 2 is equal to 4 times 2, which is 8. Now we have another times 2 here. And so 8 times 2 is 16. So this one works. Let's look at the second one. 4 times 2. Not 4 times 2. Oh, I made the mistake. 4 to the second power, or 4 squared. We've kind of seen that before. 4 squared is the same thing as 4 times itself one time, or 4 times 4. 4 times 4 is equal to 16. So that one works. All right, last one. We have 2 to the 5th power over 2. Remember, the over bar means divide. So 2 to the 5th is 2 times 2 times 2 times 2 times 2 over 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we're left with 32 over 2, which is equal to 16. So that one works. Now we're left with 8 squared. So 8 squared is the same thing as 8 times 8. 8 times 8 is not equal to 16. 8 plus 8 would be, but 8 times 8 is not equal. So this is the one that is not equal to 16. All right, the last one says write 3 expressions containing exponents so that each equals to 81. Alrighty. I'm going to let you guys do this one on your own, but one possibility is 9 times 9, or 9 squared. I would like you guys to try and think of 2 more, but you can think about maybe some factors of 9 to help you out with that. Alrighty. That's all for today. Do the practice problems. If you're confused about exponents, reach out to me. Go online to use the applet. It's really cool. I hope you got to figure out the genie problem because it's awesome. See you guys